Welcome back to the Caribou Data Science channel. It is the evening of November 20th, 2020, and I'm getting ready to run I'm actually getting ready to do a little more work on Benford analysis. I'm using the script, I'm starting with the script from Mark Nigrini. He has a very nice series of, 17 videos on Benford's Law. And I'm working here with Benford's Law Part-3, June 2020. He does an analysis of population across the country. He also has a link down here to where you can download all the code, which is what I did. And I'm trying to convert this code, I'm trying to convert it to to an R Markdown script. So I'm basically just, you know, working my way down the script here with all his numbers. Okay. And I'm using these things here as sort of section headings for the various sections here. Extract. So what we've done here so far, I don't quite understand every single piece of the code, but here he's reading some census data. Okay. Let's take a quick look at that census data, as we always do. So here's census data. So here's the census data, people 20. Nothing really fancy. So we just start up here. This eliminates scientific notation. We read into data. We determine the class. The class should be a data frame. Class for people area should be should probably be they should probably be numeric. Here you can see what are these two things here. Okay. So you can see interesting enough. This one is a integer, and this one is numeric. Then it converts this first one to a number. We just do a head for the 10, get the column names. Then we come down here next. All we do is calculating the total number of people, simply using the sum total. We format it with a comma, with two decimal places and a comma. Format the minimum number of people and the maximum number of people. Very, very simple functions. Then we simply do a string. Look at the not quite sure what that's all the way down here for, but anyway, do a string, do a summary of people 20, and then take people 20. We do it anything less than 0.1, delete the record. Multiply records 0.01 less than x less than 10. Not quite sure what this does, but by 1,000 to move decimal point to the right. Now I come down here, we subtract a substring, we pull out the first digit, we convert the first digit to a numeric number, and then we do a simple count using the aggregate function. List first. Now, that's a mistake. We probably could have used a table also, but that's okay. And then we convert this data back to a data frame. So let's come up here. People 2010. So let's just run this again here. Okay. Let's come down here. Let's multiply the numbers. Now let's calculate the people count. Count. Okay. Let's just do something here. Let's just do a table of FT. We have okay, this is actually taking the first two numbers. Okay. Okay, count. Interesting enough, he's actually using the first two columns, which is okay. Okay. Let's try this. Let's try. Okay. So, okay. So let's see something here. So this extracts the sum of digit frequencies, but it's using the first two digits, interestingly enough. So let's come back over here. Okay. So let's do this. Column name, we're just going to convert to column names, counts. So first two counts. So let's come back over here. So first two and the counts. Okay, good. 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 What happens if we let's try. Let's try. Okay. Okay. Okay, that's not right. Okay. Now we should be able to look at that and calculate the. So that's frequency is 35. Okay. Okay. So we actually have already gotten the set of numbers here. Now we could. What happens if we did this? What happens if we... Okay. What would happen if we took this count now? What happens if we took this first count here? Okay. If we came down here, we took first count, we summed count. Let's see. Okay. So let's do this. We're going to do count, colon. Okay, so let's say count divided by. He probably actually does that someplace, to be perfectly honest. Sum. This last part shouldn't work there. That doesn't make any sense. Per count. Okay, let's get rid of that then. Because I'm sure he's going to count the frequency at some point. Okay, let's come back over here. Okay, let's come back over here, check. Now we'll probably have to change this. Now, check. Is there a positive count for each possible first two digits? Okay, so let's check this. Insert this. Okay, so let's check there and see if this gives us anything. Okay, let's come back over here now. Prepare the components of the Benford table. Okay. That's really all we need, right? That's really all we need. No, we can do a table of some type. Okay, now we get down to the nitty gritty here, okay? This is the table we're really interested in, okay? So let's run this and see what we get. We get a table. So we're just on the components. See row 10 to 99, I guess it is. Count. Total observations, sum, actual, round, count. Okay, very good. So we can run this down here. Let's come back up here, put the obligatory. Okay. Okay, combined components of Benford table. So what we're looking for here is, ultimately, we're looking for a single table. Oops. Combine components of Benford table with reasonableness test. Well, I'm going to go that far. Okay. Okay. Now we get trigger. Ben test counts. Very nice. Very nice. Actual. Excellent. That's really all we're looking for there. What would happen if we did? Okay. Let's just stick with this function, with what it's doing so far. Okay. Now, since we got counts there, we should be able to do a plot. Alrighty, Dad. Okay. Okay. Now what he does is, but now that we got all these, wait, bin test. How come bin test isn't a table? Okay. People. What is that? What is class? Matrix array. Okay. So we probably want to. So here's the first digits. Okay. Here's the count. Here's the actual. Here's the difference. Absolute difference is z-test. Now the difference is, all we have to do is get rid of some of the test. Now, since he's sticking with this, see, we should be able to come over here, plot this along the lines, plot the count, and then plot Benford. %41. Okay. Okay. So that's the matrix. Okay, let's come back over here. And let's write this as it says. Yeah. Okay. Okay. So let's do this here then. See what this does. This writes the table out. Bin test. Let's open up this. Okay, so now we got this point over here. So let's do the digits. Let's do a digits. Let's do a count. Okay. Okay. So why this isn't working is because it doesn't want to take this. Oh, we want this on the x-axis, this on the y-axis. Okay. 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 Now, what we're going to do is bin test. Let's do this first. So let's. Okay. Okie dokie. So now we got that portion done. Come over here. Now, now, second. Okay. First and second digits. First digits count. Okay. Okay. This is okay. Okay. Now, what we should be able to do here is, since we got all these numbers, okay, okay, plots, okay. So let's go, let's do the data frame, bin test. So now we got this. Now we should be able to start off with a simple plot, okay? Okay, let's start with something like this. First, after here. So what she needs here is BNFRD, colon, comma, count equals. Okay, so what are the options here again? Okay, points, lines, both, or the lines part of blank, or both of a plot for histogram. Okay, let's try histogram, see what happens. Okay, so this is the count, okay, and this is the digits from 10 up until 600, okay? Now those are current. The trouble is these are all, so that's the first thing. Okay, actual Benford. Now let's do this. Let's see, actual, okay, index. So this is, should be, so let's try switch, so let's try one more. Benford. Maybe it's lines. Okay, so let's come back over here. Let's do this instead. This is the Benford number, right? So let's change the first one. So the the curved line, the jagged line is the actual number percentage. Okay, the curved line is the Benford numbers. What we want to know is we want to know what the difference between Benford. What we can do is let's see if this works. Well, it does work good. So okay, so we got the actual with the Benford. Now let's plot the so here's the difference between the actual. Okay, the difference is okay. Okay, so the difference doesn't do us any good. Let's do this. Okay, so this would be the difference. Okay, the difference is most 400ths of a percent. Okay, that's not very useful. And for first two digits, Benford uh, actual hits. Okay, okay, let's see some here. Okay, so here we go. We got the counts, right? Counts, first two digits. Actual percent. No, it's a line. Actual versus actual. Okay, actual versus. So here's your counts. This would be your percentages then by group. So the red is the actual expected values. Let's do this here. Okay, so this is actual versus Benford. Okay, excellent. So here you can see this here looks pretty good, doesn't it? Let's see something here. How long have we been on here now? 37 minutes. Okay. What would happen if we came down here? So, okay. What happens if we do this? Let's see what happens here. Okay, that doesn't really help a whole lot. That doesn't really help. Okay, so we come down here. We convert a data frame. So that doesn't work. Okay, so we basically have the two basic plots we're looking for. We're looking at the count of the first digits, and then we're looking at the actual versus the Benford expected numbers. So let's try to run this here once right now, okay? See exactly what happens. Okay, so this is just the numbers, the area and the people. That's minimum max numbers. Where's this at? What do you want to actually print these out? Data frame, let's see, state. This is nothing new here. Uh, the average of people, so you got the mean of 98,233 people and a max of 9.8 million. Not really sure what these do here because you don't print out the names or anything like that. Create the Benford table. Okay. So now we have this here. The first two digits, the count. The actual percentage is 41%, which is probably too high. And the Benford, which is 41%. So these would appear to be okay. Difference here, absolute CCAT, tail, more the same thing. Okay, counts. Okay, calculate the mean absolute numbers. Plot Benford's law. So here is basically the count of the two digits. Okay. This is a plot of the red line is the expected Benford number. The underline are the real Benford number. Let's try this. Let's try to change these down here to bar plots. Okay. So we got this here. Plot first digits. Digits and count. Actual. Benford. So let's try this. Let's reverse this. Okay, we're not going to bother. We know what. Let's do this. Okay. We do a histogram of frequency. Okay. So let's come down and try this. Actual. Why do we have this here? Frequency. No. Okay, so this doesn't actually work well for a histogram. Okay. Now. Okay. So once again, let's take a look here. First, these are the actual first two-digit counts. Okay. There is some volatility there. That's true. These are actual counts. And this is the percentage here, the actual percentage. Okay, though there's some volatility, but you do see some numbers up here. Okay. Okay, so this is the end of part one. Oh, maybe let's come over here. Let's find a spreadsheet. Okay. So here you see 1 through 9, second digits. Okay. Okay, so technically that I should have this over here. First digits, I don't actually have first digits. Okay. This is only first two digits, right? Okay. This is first two digits. Okay. Let's save this. Okay. Now if you come back over here, open up bin test. Okay. So first two digits. If we come over here, delete this here. Let's just do this. Let's get rid of this. Okay. So let's come back over here now. Let's do this. Okay, so you plug those in there, and that gives you all this information down here. First digit, count, makes no sense. Okay, did that actually work? That's a good question. Let's, tables, okay, profiles, first digits, okay, second digits, first two. Okay, so we're not really sure about that at this point. But the main thing is, let's run this again from the top, shall we? Let's get rid of some error messages up here. Let's see, we got errors, messages, warning. Okay, so let's run this from the top. So we're essentially doing the same thing here. Okay, this is the actual counts. Okay, this is the actual counts. Okay. Now if you come down here, these are the actual percentages based on the first two digits. Okay? You can see exactly what's going on here. This is the red line is the expected Benford number. Okay? And this is the actuals. So so this isn't all that bad, actually, to tell the truth. We should be able to let's try that over here. You know what? Okay, so let's do this. I'm normally not a big attach attach. Okay, R plot. So let's try first of all. Let's try digit I. Okay, so let's try this. Oh no, it's FTB count. Digits. So we try. Let's do counts first. Digits. Yes. IST. So there's a count. Okay, this doesn't make any sense. So it wasn't really that helpful. We actually went down on the bottom, not the top. Okay, so let's call quits at this point for this first round. One more time from the top. Okay, as we say, this is really the main thing we're looking for here. Benford curve, Benford expectations. Okay, actual percents. Okay, come up here, counts. So that pretty much takes care of this Benford analysis for today. This is using Mark. This again was using Mark Negrino's R script. an R script which makes no use of of any packages. So I added 2 plots at the bottom, which is basically the most basic plots of all. So anyway, thanks so much for your time. We'll catch you on the next report.